In a trapezium ABCD, where AB is parallel to BC, AB equals to 2 times BC. Okay, AB equals 2 times BC. AB and AD are vectors. Okay, AB and AD are vectors, B and vector D respectively. Okay, AD is vector D. Point M lies on AB such that AM is to MB, AM is to MB is 3, which means we can say AM is equal to 2 over 5 AB and MB is equal to 3 over 5 AB. The point N lies on BC such that BN is to NC equals 1 is to 2. BN is to NC equals 1 is to 2. So we can write down BN is equals to 1 over 3 BC and NC is equals to 2 over 3 BC. Find the vectors we have to find out. AN, CM, AC, and BD. Fine. Fair enough. Let's try this. Okay. First of all, we have to draw a trapezium, and this is about AB and BC. So we can draw like this. Okay, AB parallel to BC, and AB is equals to 2 times the BC. So this should be A, this should be B, this should be C, and this should be D. Now it works. And now they have told us AB is vector B and AD is vector D. And they have also told us AM is to MB is 2 is to 3. So it's somewhere here, M is somewhere here. If this is 2x, this should be 3x. That's the idea. Okay, that's the ratio we are using. Then we have DM is to NC. So somewhere here. If it is x, this is 2x. That's the idea. And we have to find out AN first. This is N. Okay, let's find out AN first. To find out AN, we can go from AD to DN. Okay, but we have to find out also DN. Yeah, if we know DN only, we can find out. But we know DN is equals to what? 1 over 3 DC. 1 over 3 DC. But the thing is, we know DC is equals to half of AB. And we know AB in terms of P. So that's how we are going to find out that. Find that out. So first one, we need to find out AN. We know AN is equals to AD plus DN. We know AD. AD is equals to D. That doesn't matter. Now we have to find out DN. DN is equals to 1 over 3 DC. What is DC? DC is equals to half AB. And the good thing is half AB is half D. So this will be equals to 1 over 3 into 1 over 2b, which is equals to 1 over 6b. So this will be equals to b plus 1 over 6b. This is how you have to find out AN. Similarly, we can find out CM too. Okay, CM is also not that hard. Okay, we have to find out CM. We know to find out CM, we can go CD, BA, and AN. Okay, we can go from CD, BA, AM, or we can go CB and BM. But for that, we have to find out CD. Whatever the method that you like, we can follow. Here, I'm going to use CD, BA, AM. Okay, fine. So, second one, CM is equals to CD plus BA plus AM. Well, CD is negative DC plus BA is negative AD plus AM. Well, AM is equals to what? We need to find out AM. We will find out AM. That's not an issue. So what is AM equals to? AM equals to 2 over 5 AB, which means it is equals to 2 over 5 E. Cool? Yes. Now we know minus DC. Why? Minus DC. We already found out DC. We already found out DC. DC is equals to half B. So minus half B plus we need to find out AD. Well, AD is given, so it will be minus B. Okay, so we have this, and we have AM. AM is plus 2 over 5 B. Clear? Yes. Now we can do some rearranging. So we have 2 over 5b minus half b, which means 10 over 5, and here we have 10 over 4. So minus 4 over 10, yeah, minus 1 over 10, minus 1 over 10, 1 over 10. So we have minus 1 over 10b, okay, minus d. So Cm is equals to minus 1 over 10b minus d. If you want to recheck, you can also do that. No issue. You can also do that. Well, how are we going to do that? Hmm. Mm-mm. Okay. First of all, I'll erase these things. Okay. I'll erase these things so that we could find the answer. And okay. What is it? AC and BD are the diagonals. Okay. So, other way to find this out is we need to find out CM. To find out CM, we can say CD plus DM. That is also doable. Yes. Fine. What is CB? Well, to find CB, we have to go from AB to BC. That's one way. Okay. We can go from AB to, CB. Yeah, to find out CB, we can go from CA, okay, CA to AB. That is one way. So, CB is equals to CA plus AB. Well, CA is equals to CD plus DA. Okay. So CA is equals to CD plus DA. DA is minus AD and CD is equals to minus half DC. CD is equals to, CD is equals to minus DC. So this will be minus DC minus AD. And we know DC is equals to 1 over 2 B. So minus half B, and AD is equals to D. So minus AD is minus D. So we have found out CA. What about AB? Well, AB is given B. It's given as B. So CA is equals to minus half B minus D. Okay. And then we have A, the AB, which is equals to plus D. That's done. And now we have BM. We know BM is MB opposite. Okay. BM is equals to negative MB. And we know MB is equals to 3 over 5 AB. So it will be negative 3 over 5 AB. And we know AB is equals to B. So minus 3 over 5 E. So here we will have CB is equals to, well, we can cancel it out. So it will be half B minus D and plus BM, which is minus MB, which is equals to this. So minus 3 over 5B. And this will give us again minus 1 over 10B minus D. So in both ways, you will be getting the same answer. Now we have to find out AC. Okay, now we have to find out AC. We know AC is equals to AD plus DC. Okay, so it will be AD plus DC. The thing is, we have already found out CA, so the answer will be plus half B plus D. Okay, but let's do that also. So AD is equals to D, DC is equals to half B. So this is the answer. So we have half B plus D. Then we had to find out, I think, DB. Okay, DB is equals to DC plus CD. So we know DC is equals to, well, we have to find out BD. It's easy to find out BD actually. Yeah, it's easy to find out BD. So we'll just do BD. So this is equals to minus BD. And we know minus BD is equals to minus BA plus, well, I'll write it down separately. We know BD is equals to BA plus AD, BA plus AD. So that is equals to minus AB plus AD. So that is minus B plus B. And that gives us D minus. So dB is equals to D minus B. And dD is equals to minus B plus D. This is how you have to do this specific question. We have another question that says in a trapezium PQRS, okay, so trapezium PQRS with PS parallel to QR and PS is equals to 2 times the QR. So yeah, let's write that down. So PQRS PS parallel to QR. They have written it down in different way. Okay, that's great. So we have P Q parallel to Q PS parallel to QR, PS parallel to QR, PS equals to 2QR. Point M lies on PS such that PM is to MS is 1 is to 1. I see. Okay, fine. So they have told us PM is to MS is 1 is to 1, which means PM is indeed equals to MS. And yeah, that's great. So that means PS is equals to 2 PM and PS is also equals to 2 MS. So we can say PS QR. So we can say PM is equals to MS is equals to QR. PS is vector S and PQ is vector Q. So we have to find out PR and then QS and then MR. That's the question. Superb. So let's draw the trapezium as we normally do. That's very important. Okay. Now we can write down PQRS or PQR. This way. PQRS because PS is parallel to QR. Yeah. And PM is the center. So that's great. Fine. So is it the center? Yeah, it is the center. Okay. So first of all, we have to find out PR. That's easy because we know PR is equals to uh this is S and this is Q. That's what they have given us. So PR is equals to PQ plus QR, and we know QR is equals to half PS, and that is half S. So this will be equals to Q plus half S. Then we have QS to find. QS is equals to QR. Oh no, it's easy to go from QP to PS here. QP plus PS. And we know QP is equals to what? Minus Q? Yeah. So minus PQ, we can say. QP is equals to minus PQ plus PS. And that brings us to minus Q plus S. So we have S minus Q. And third one, we have MR. So we have to find out MR. MR is equals to, how can I say, MS plus SR? Yeah, MS plus SR. Mm-hmm. Yeah, that's easy. Or I can say I'm going from MQ to QR. That's easy. Yeah, that's also possible. And then we have to find out NP, PQ, then QR. It's easier. Yeah, it's easier. So, oh, should I go MS to SR? But how to find out SR? Well, SR is equals to SQ plus QR. That's also easy. Well, whatever it is, we'll just use MS plus SR. That's pretty easier, I think. So first of all, we have to find out SR. SR is equals to SQ plus QR, and we know SQ is minus QS plus QR, and minus QS is equals to Q minus S. Why we know QS already. QS is equals to S minus Q, so minus QS must be Q minus S. And then we have QR. I think we found out QR, that is plus half S. So we have Q plus half S. That's what we have for SR. And we know MS, yeah? MS is equals to what? MS is equals to, well, that is equals to QR. So we can say, well, that's equals to QR. So it will be QR plus SR, and QR is equals to half S. How do I know that? Well, I found that out. Plus, ah, well, it should have been this way because we know, yeah, it's fine. Half S plus SR is Q plus half S. Yeah, Q plus half S. Q plus half S. So that will be equals to Q plus S. So that's great. Now they're asking us to show that vector MR, okay, vector MR is parallel to PQ. What is PQ? PQ is Q, MR is Q plus S. How can it be parallel? MR is equals to MS plus SR, and we know MS is equal. It's not QR, right? MS is not equals to QR, right? MS is equals to QR. Yeah, MS is equals to QR. So QR, yeah, MS is equals to QR. SR, SR did we find out? Yeah, SR we found out here. Huh. Minus half is right here. Yeah, we made a mistake. Yeah, obviously, careless mistake. Minus half is. So we had to change a little bit here. Okay, so this will be minus half s. So this will be minus half s. So we will get q instead of q plus s. Okay, we will get q. So now we have done with three questions. The fourth question is show that vector MR is parallel to PQ. To be parallel, okay, to be parallel, keep this in mind. If two vectors are parallel, okay, to show that two vectors are parallel, we have to show, let's say if we have AB, okay, if we have AB, and if they say AB is parallel to CD, that means AB is equals to lambda CD. Lambda can be any value. Lambda can be any real value. Lambda can be any real value. Okay, lambda can be any real value. Okay, keep that in mind. Okay, well, wait. Can lambda be any value? Yes, it can. So lambda can be any value. So like that, let's say MR is actually equals to PQ. Why? We can see that. Why is that true? Well, MR is equals to Q and PQ is also equals to Q. Yeah, MR is equals to Q. PQ is also equals to Q, which means MR is equals to PQ. This means MR is parallel to PQ. Determine the ratio of their magnitudes. Well, 1 is to 1. MR is to PQ will be 1 is to 1. Okay, so keep this in mind. These are some of the questions that you can perform to understand how vectors work. Yeah, pretty easy, right? Okay.
Thanks for watching the fifth video in our vector series. If you found these position vector practice questions helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.